Good morning, good afternoon, everyone. Welcome to our featured webinar on testing Adobe Flex. As a matter of fact, not just testing, but really quick testing of Adobe Flex applications. We are very glad to have as a featured guest today Mike Labriola. He is an extremely well-known name in the Adobe community. He is a founding partner and senior consultant of a company called Digital Primates, one of the premier consulting companies helping clients build enterprise Flex applications. He is very well known for his presentations, work on open source Flex, and other contributions to the Adobe community. I'm Sergey Sokolov, Director of Product Management for Test and Performance Tools at SmartBear Software. And today, we are going to talk about how to efficiently test Flex. We are going to feature TestComplete, SmartBear TestComplete, which is an automated testing tool from SmartBear. We'll discuss where it actually fits in the stack of test methodologies. Then Mike will discuss the initial pain of automated functional testing of Flex. Unfortunately, there is one. Different people solve it in different ways, but there's no denying it's a little bit away from straightforward. We're going to cover some aspects of the ongoing work to maintain these tests as required by the more traditional test approaches, and then switch to show the benefits of how TestComplete can simplify testing of your enterprise Flex apps. We will show a demo towards the end of the presentation with a Flex application made mostly out of custom components, and see how you can really quickly set up the test, validate the properties that you're interested in, and then we'll open up for questions and answers. So Mike, over to you.
Sure. So we're going to talk here through the various types of testing types just very briefly. When we talk about testing with TestComplete in the Flex stack, we're specifically referring to functional testing. Now, within our application within Flex, we may choose to do any of the three types, and hopefully all of the three types of testing, including unit integration. Those types of testing are relatively low level. They require code that's architected in a very solid way to begin with before we actually begin the testing process. Functional testing isn't going to cover the same pieces that we can do with unit integration, but it's a really solid way to make sure that the application functions as expected, or more specifically that the application performs towards the goals and possibly a better way to put it is the requirements that we've established for the application. When we interact with button A, this thing happens. When we interact with button B. The reason that we want to look at all of these is that unit is usually a fundamental way to make sure individual pieces of code that we want to reuse in the future work properly in and of themselves. Integration is the way in which we make sure that those individual units work together. And then functional is the way that we make sure that the assembly of those units and those coupling of units works together for the entire application. So to that end, what we'll actually do is talk a lot about functional testing in Flex. And because Flex is this web browser environment where we're going to work back and forth with different sorts of pieces and interactions, there's some complexity. There's some complexity in the way that Flex works and interacts with testing tools such as TestComplete. So we're going to, as Sergey mentioned, talk through a little bit of that pain next. All right, so testing Flex, right? In a traditional application, and this is kind of the unfortunate truth of it, if you're going to use only standard off-the-shelf Adobe components, so no custom components of your own, then really any of the functional testing tools on the market will do a good job for you, and that's good. There are a number of applications on the market that use just standard tools. However, when we actually get to enterprise Flex applications, the chance that we're actually, in our experience at least, the chance that we're actually going to produce an entire application and have it only use standard Flex components, no custom components whatsoever, is about 1%. And so while we have this great solution and things work relatively well out of the box if we use just those components, the reality of doing our application, the reality of actually testing it is relatively small. Now, why is this? Well, it's because of the fact that Adobe actually has gone through a lot of trouble to make their components work properly with testing environments, a fair amount of engineering. And the expectation is that you'll do that same engineering for your components if you want them to work. That's not always obvious from the beginning, but that's actually the expectation of how Flex works. Okay, so let's go ahead and we'll go to the next slide here, and we'll talk a little bit more about what those pain points are. So traditional process, right? I mentioned Adobe's done a lot of work. Well, our traditional process of how we would go through things is that we have to, before we begin testing, and this is a very important part here, before we begin any functional testing of our Flex application, we have to create our components, which is fine. That's an expected engineering time. But there's two more steps. There's this step of creating a component delegate, and there's sort of an updation of what's called a configuration file, or a file that's going to allow us to interact with the actual Flex code at the time in which we are running our one-time tool. So on the next slide, what we'll see is sort of the process of how a delegate works. You see, what it does is it acts as a mediator between the testing tool and the Flex component. The testing tool talks to this code in a delegate, and that delegate understands how to talk to the actual Flex piece. So as you can see, that delegate's a necessary piece between the testing tool and the Flex component in sort of the traditional methodology of how these things work together. Now that's fine. It's okay that there's some piece there, but what that means is that there's this delegate code that has to exist and it has to perform a minimum number of tasks. So some of those tasks we sort of enumerate on the next slide here. We need to have a delegate which identifies and provides access to each child. What does that mean? Well, let's pretend we have a data grid. Each of those rows in our data grid are considered a child. So our delegate has to be able to teach the testing tool about how many children are there, what exists, what doesn't exist. It has to enumerate each of those children so that the testing tool later on has a way to come back and say, I want the third child or the fourth child. In dynamic components, such as something like a data grid or a data group, it needs to watch for changes in the number and type of children. So, for instance, when a new child is added or a new row is added or one is removed, those pieces of information need to be available to the testing tool so that decisions can be made. Then it gets really sticky, which is that we need to identify and capture all events that come from this child. So in other words, if the child's been clicked on or if it's being hovered over. All of those might be things that you decide to do within your application. So in other words, maybe what you want to test is that when I hover over a row of a data grid, a certain tooltip comes up with certain information in it. And that's fine, but that means that every one of those rows, we need to be able to capture everything that might happen, every interaction you might do with your mouse or keyboard, and then report to the testing tool what just happened. So in other words, this row's been hovered, this row's no longer hovered, this one's been rolled over, this one's no longer over. All of those things are captured and sent along to the testing tool. And then we record each one of those events in what we sort of have this record mode. And that's really what the testing tool receives. So the testing tool receives this recording of all of the various events that have happened to it. And that's fine. It's good to have that recording. But then it turns out that later on, even after we have that recording is given back to the delegate, and the delegate is responsible for doing the replaying. So the testing tool says, someone did click on you, and then the delegate is responsible for saying, component, pretend like someone just clicked on you. It's that back and forth piece. I'm actually going to take a moment to show an example of the delegate just to put something in a little bit more concrete mode here about what that would look like in the course of doing this sort of thing. So, in a traditional delegate, and let's look at a couple of the ones that are here for a moment, we might have something that looks a bit like this. We have this it's a relatively simple class, right? But it's a class nonetheless that exists that we would go through and declare. And as I was mentioning, what we actually have is the ability to return things, and we have these sorts of methods that say, okay, we're going to replay events. And so we have to have a piece of code that accepts every type of event, and then this is a piece right out of the Adobe framework that says, okay, well, if it happens to be a mouse event and that type was click, then we're going to go ahead and replay a click. And if it happened to be a keyboard event, then we're going to go ahead and figure out where our scroll position is, and if that scroll is there, then go ahead and replay our event. So this is something that's actually written for some of the Flex components with Adobe that are right out of their framework. Now, that's fine. Yes?
Mike, just a question.
Sure.
Are you saying that all this code needs to be custom written by the developers of Flex application?
What a leading question, Sergey. And yes, we'll talk about that too. But yes, what it means is that the code right now, if I just wanted to use, for instance, the data group or the data grid, And if that was the only component I was going to use in my application, Adobe's done that work for me. But what it also means is that this work, for example, this particular class is 280 lines, but if we actually go through, it's only 280 because it already extends something else, so we might have another few hundred here that we actually have to look through to get everything. What it means is those couple thousand lines of code, if you're using Adobe's components, were written for you. But if you wrote your own component, you may very well, especially if it's not based on something very similar to Adobe's, you are going to be very much responsible for creating and maintaining that stuff on your own. And we'll certainly talk about those implications. Now, in addition to this code that actually has to be written here, when we actually go through, we also have to create a configuration file. Now, after we have that delegate, this configuration file is created, and it sort of indicates the properties and events that the testing tool should notice. So in other words, the delegate is responsible for talking between the component and the testing tool, but the configuration file traditionally tells the testing tool what's available to it. In other words, this component will be emitting this event. This component does have this property. This component has this sort of thing you can do to it. That XML file gives sort of the domain of possibilities, is the way that's often explained to it, of what the testing tool is allowed to do and how it's allowed to interact with the component. Now, not only must that XML file be created, then that XML file actually has to be distributed to each workstation where testing occurs. So that XML file is given to each and every workstation. Now, just to give you an idea of the complexity that follows there, for a reasonably sized library, here's a quick example of one that is created for a client of ours. I've changed some names to go through and make this a little less identifiable, but this is about a medium-sized library. And here is the XML file that we had to create to maintain that. Now I'm cursoring through a few pages, but let's just go ahead and jump down to line 26,506 of the custom XML that we actually had to create for this particular client. And as you'll see in here, it says for every property, X is there, and whether it can be verified, and the description of that property, what type of thing it is. This one's a number, this one's a string. All these sorts of pieces of information are present and give the automation tool or the testing tool the necessary information it needs in order to make those decisions. Now everybody's already looking at that and can see it's a fair amount of work, but let's talk through what that really means. We establish a number of problems here. First of all, we have this component and this delegate. How do we keep them in sync? And this is really the number one problem when we get to this. Every time we change our component, we need to make a corresponding change in the delegate. If our component now emits a new event saying something has been hovered, we have to go to the delegate as well and make sure that the delegate now understands how to receive that event and replay back that event. If we don't do so, we can cause very erratic results. In the best case scenario, things may not get captured, meaning that the testing tool won't know something was hovered over, so later on it simply won't tell the application something was hovered. In certain cases, that could mean that the test doesn't run as well as it once did. In certain cases, it could actually hide an error because perhaps only the error occurred when you hovered over something, and now since that hover event doesn't actually exist anymore, an error is hidden that really isn't happening inside your test. But the big problem here is that the one engineering effort causes another. It's not a non-recurring engineering scenario. Instead, every time we do component development, we have to go forth and we have to create and maintain these delegates as well. And doing that ends up adding a significant amount of time. Further, there's some coordination problems there too, which we'll talk about, is who maintains those? Are they part of your engineering team? Is it part of QA team? How does that all work out? Now, in addition to that problem, we have the errors. What happens when a test fails? We now have two pieces of code. It's the old adage that a man with two watches never knows what time it is. What happens when we have an error? Is it the component? Or now we have a delegate. Is that delegate broken? Because it could be that the component's working fine, but someone made an error in the delegate, which is causing our test to fail. So we have two pieces of code that need to be maintained. Each piece needs to actually be tested individually, as an error in either could be the source of the failure. And the biggest problem here is that it leads to an error of identification and responsibility. I've seen large organizations where the QA department is in charge of maintaining those tests, and development have been in charge of creating the code, and then there's a few people in QA who are maybe trained a little bit more to be able to create those delegates. When we have three teams of people trying to identify where a problem happened each and every time a test fails, it turns out not to only be inefficient, but can quite literally be maddening while somebody tries to establish where it's at. Also, testing the delegates and writing tests around the delegates is its own problem. If you do very good unit testing of them, you can, in fact, test them, but it literally means we must have unit tests around all of those delegates, which, again, while I think is a positive thing, is an engineering effort. Now, we also have this decision thing. There's no prescription on how you write delegates, and there's levels to which they can be written, and these levels can actually be another problem. See, our delegates can actually encapsulate a whole lot of behavior. So imagine we have a data grid. Our delegates could simply tell the testing tool a row has been selected. Great. We know a row has been selected. Maybe we can get the data. Or our delegates could encapsulate nothing, and instead of saying a row has been selected, they could point specifically and say this item inside of this parent, inside of this part of the screen, has just been clicked on. And so that means that they have very little encapsulation. They're very exposing. Well, there's problems with both of them. If we have too little exposure, or if we have too little encapsulation, rather, we have a lot of exposure, which means that every time we change even a little bit of how the internal of that component works, we have to go off and rewrite the delegate. Because not only rewrite the delegate, or rather, in some very bad cases, rerun the tests. If you can imagine, if instead of knowing that a certain item was selected, if your test knew that it was the 33rd item in a list on the screen, then when you have 34 items next time, your test can't possibly work the same. Those things fail, the order in which things exist. If instead of it being inside of a vertical layout this time, I put it inside of a horizontal layout, that could change things and my test may fail. So we have some piece of code that works perfectly well, but our tests become invalid because we've exposed way too many details to the outside environment about the inner workings of our component. Unfortunately, the other side's true too. We could simply make it say, our component say, hey, the third item is selected, the fourth item is selected, which means that we have very portable tests. They work very, very well. However, it could be that actually clicking on one of those rows for real causes the component to explode. Maybe some animation fails internally and there's an error. But since our tests are now dealing at the component with such a high level, we're just indicating that something was successfully selected, but that doesn't necessarily mean something was clicked on successfully or an animation successfully moves something to the right position. It means that we can have tests that appear to pass, even though in practice when somebody tried to use the component it would fail. So having both of those sides of it can actually be quite frightening. It becomes a balance of trying to figure out how we write our delegates and at what level. Now, we have another problem, which was the configuration file. In addition, once we have all of these delegate things worked out, we still have the need to distribute and synchronize the distribution of XML files. If we have a team of testers out there, how do we make sure no one's using the wrong version? Especially when we have a scenario where that information can change quite readily. Someone from a new component is released, and by the way, on one of the sort of side notes, many testing tools allow exactly one of those XML files for any given project, which means that if I have a constantly evolving library of components that people are adding to, they have to continue to update that single XML file. It becomes a version synchronization issue, which can all be overcome. But as we continue on, we have to distribute that XML file to every one of the testers. And if I have a whole bunch of them and one of the testers out there has the wrong version or hasn't updated, well, two things can happen. It means that one can create a test which works properly on their machine but fails on all others, or it could mean that a test created on a machine that actually had a proper XML file will fail on someone who doesn't have the right one. In either way, it means that now we have another layer of unpredictable nature. We have another layer where the testing machine itself and the configuration file that that machine has is going to make a whole difference in how we actually execute those tests and what runs where. It basically becomes a problem with a lot of moving pieces. And all of these moving pieces work and happen this way because of something called the Automation API. The Automation API is the way in which these delegates in this configuration file for different tools interact with Flex in order to work through the automation. Now, the interesting thing about TestComplete, and the reason we're talking about it, is that TestComplete avoids this automation framework completely. And why that's really important is that it avoids any bugs that could be introduced by those delegates. We're avoiding the cost of maintaining that automated code that has to be testing. And possibly most importantly right now is that we can start testing immediately. We don't necessarily have to wait till the automation work is done. And that's why for us it tends to be kind of interesting, because not only do we end up being able to use TestComplete to test an entire application, but we make small little stub files in places where we can test an individual component at once, because we can start this process of testing right away, not through the process of doing this. So basically, if we actually avoid that complexity of the automation time, we have less engineering time, at least less engineering time on these delegates, which means we can redeploy those resources somewhere else. We're simplifying our deployment to QA, and it really does mean we have an overall simplified process. And honestly, within the context of what we're doing, having less points of failure, having less points where things can go wrong, is a huge deal to us. So with that, what I'm going to do now is I'm going to turn over things to Sergey for a moment and let Sergey go ahead and demonstrate how we test a custom component, and actually an application built with custom components inside of the TestComplete tool. The TestComplete tool is going to allow us to see these custom components. Even though we haven't gone through any of those steps we described, we won't have that capability of, or won't have the necessity, rather, of going through and making the automation API files first. We aren't going to have to worry about that XML file. Instead, without any of those things present, on the very first time that this application is taken, we can start doing some tests, and that's pretty impressive. So I'll go ahead and turn this over to Sergey, and I'll add as we continue going along.
Thank you, Mike. That's certainly a very interesting view on developing tests, obviously from somebody who's experienced that day in and day out. And of course, as our audience probably realizes, that if you have just a little game that you're developing or small client, these issues aren't necessarily as pronounced, but if you scale up to hundreds of thousands and million line of code, a large team of developers, a large team of testers who possibly sit at different locations, the problem becomes of quite different magnitude. So what I would like to talk about a little bit is how TestComplete, by avoiding using the automation API, which was a conscious choice at some point in the past of our tool development, helps users get to testing faster, spend less time developing tests, and less time maintaining tests. Just before I go into my part of the presentation, I just wanted to remind everybody that we do have the ability for the audience to ask questions. You can do that via the questions panel on your GoToWebinar widget. As we get these questions, we'll review them, and we plan to leave some time at the end of the webinar to answer them. So your questions are welcome. Before we actually go to the demo, I presume not everybody is familiar with TestComplete, so I'm just going to go and talk about what that is. TestComplete is about 10 years old. It's a very general functional testing tool for the Windows platform. It tests pretty much anything that can run on Windows. It can test web applications, whether it's Java, PHP, with rich internet content, Plex, Flash, Silverlight, Ajax, and so forth, you name it. It made its name in the client-server .NET apps, where it's still probably the #1 tool out there. As I mentioned, it can also test Java applications, standalone native apps on Windows, but also web services, which are lower level tests than you would do specifically against a GUI, and it has some support of unit tests as well. So it's, as you can see, it's a very capable tool, and given its wide spectrum of capabilities, it can be used very widely in the validation process as well. It can be exploratory testing, where you just click through the application and you record that, make a test out of it. Regression testing. If you record a test, you are able to run that over and over again. Structured verification and validation, where you actually have test plans, and you need to enable test traceability, and all your tests need to pass, and so forth. And it also conveniently supports distributed testing, which I will explain in the next slide. It also has very good infrastructure integration. It can not only be run from the desktop in sort of an individual user mode, but it folds very well with almost any kind of build management system, the command line interface and CLON interface that it supports. And it also has links to a number of defect tracking tools, so if your test fails, you can automatically file a defect from within TestComplete. As I mentioned, we don't just provide a testing tool, we actually look at the test management solution. And some parts of the test management solution are, apart from just having a tool where you can create and run the tests, which is TestComplete itself. There are two other significant components of a solution that I would like to draw attention to. Test management. Test management, defect management, some sort of system where you first write what you actually want to test, then you have some reports of how the tests ran, and then you can keep track of defects that resulted from the testing. TestComplete has direct interface to another set of SmartBear products, DefComplete or QA-Complete. These are web-based development, project, and test management tools. So it can be automatically run from DefComplete or QA-Complete and send data after the execution. But at the bottom of the picture, we have another convenient part of the package, which we call test executes, which are small, lightweight, inexpensive clients that can be driven by TestComplete to execute distributed tests. With pretty much any other functional testing tool, if you want to run tests on 10 machines, you need to buy 10 licenses of the tool itself. With the TestComplete package, you can acquire one license of TestComplete and however many of these agents that you intend to run on distributed nodes, and that will enable you to control the test execution from just one machine where TestComplete resides. The tests will be run on distributed nodes, and they can be independent tests or they can be dependent tests, so that if you, for example, in the client-server architecture, need to run certain setup steps and then check what happened to the back end, that's very easy to do. And as a result, the flexibility of the solution increases and the cost of solution decreases, both of which are very good things, particularly for enterprise deployments. So now, how does TestComplete test Flex? We have three methods by which we allow users to inspect how Flex applications work, create tests, and replay them. None of the three requires, as we mentioned, the use of Flex Automation API. And the top two, using the debug flash player and the runtime loader, do not require any changes to the code, any changes to the build process, any changes to your Flex application, which is why we'd like to sort of promote them. There is a fallback option where when you build your Flex application, you link it with our Flex client library that contains the necessary test hooks for us to work with the Flash player. But that's somewhat less preferential option that's used in corner cases when one of the two most recommended approaches doesn't work. So what we would like to show you today is, as I mentioned, using TestComplete on a custom build Flex application. It has some like, I don't know, it has a little bit of standard Adobe componentry, but most of the code is custom for the controls.
Yeah, I'd say there's a split between the two of them, as is in most Flex applications. Things are built upon standard components in lots of ways, but with extensions, and then there's entirely other portions of it which are completely custom, built from the ground up without any of those major pieces that Adobe provides.
All right. So we're using the application straight as it builds for deployment. We prepared the setup with using runtime loader, which essentially dynamically preloads a library into the browser that enables us introspecting the Flex application. We need to have an extra HTML page and a separately built Swift file that gets loaded in the browser, and then that enables testing of the application we actually want to build tests for. Now over to TestComplete. We're looking at the standard UI of TestComplete. It has three major parts. The Project Explorer on the left, where you basically have representation of all your test artifacts. The keyword tests, and these look like what you see on the screen. These are tests that have a completely graphical representation. Every step in the test is basically an icon that can be dragged over, and that represents a certain action on the screen or to verify the results. There's a container for scripts. TestComplete supports both ways to create tests. They can be recorded from just exercising the application, or they can be scripted. 5 scripting languages that the tool supports. And there are also other test artifacts, for example, name mapping that we use to keep track of objects that can dynamically change the names. Also build some infrastructure for easier object recognition. Stores will have data files that you can use to parameterize your tests. And tested apps are just basically configurations for running tests, one of which we're going to use. So I'm going to start recording a test. With TestComplete, it's actually painfully simple to create a test. Once you've created the configuration, you would run a recorder. The recorder will pop up a web browser. The web browser will load your Flex app or the page that contains the Swift file. And then you interact with the app, and at the points where you need to put validation actions, you put validation actions. So let's see how that would all work. I'm going to start the recording. I'm going to select a pre-configured test scenario with this Market Info application, and that will bring up a test browser with a grid that has a bunch of stock quotes from some distant past, as it appears, judging by the numbers that there are.
Indeed.
It's a sort of a typical view on a stock dashboard. All right, so we have some data here laid out in a grid. We have the entertaining symbol strip, where, depending on what you select in the grid, the symbols would slide over and get emphasized, and 3 panes that present some data regarding the selected stock. So the first thing that we'd like to verify is if we select a symbol in the strip, we get the symbol appropriately highlighted, we get all the appropriate selections and the data presented in the panes. So I'm going to select eBay. So that's going to move to the middle. We're going to get the eBay selected here in the data grid, we are going to have the quote displayed here and some data about the company, the officers, and so forth. So what do we want to actually do for validation? Well, first of all, we want to make sure that when we select this icon, it actually is the selection, that it's eBay, that it has the right quote, and so forth. So we are going to create a checkpoint to validate that. And in creating a checkpoint, we'll illustrate how deeply we can actually introspect the Flex objects that are used in this particular application. And if I'm not mistaken, this whole scroll bar with icons and so forth is completely custom code. Is that correct, Michael?
That's correct. So two things that are actually really interesting about what we're looking at here. First of all, this application is built, obviously, as you saw, with some standard Flex components and also some custom ones. That icon bar is completely custom, built on UI components, and there's a little bit of a question on there which we'll address later in the question window, but that middle strip bar there actually uses completely dynamic children. So it uses a data provider, and it renders those children based on what comes into the data provider. Now, the couple of interesting things about that. First of all, none of the automation APIs are linked into here, meaning that even Adobe's code, which links into and provides all these delegates and things like that, has not been linked into this application. So when we talk to even the standard components, we aren't using any of those automation APIs. We're using TestComplete's capability of introspecting them directly. And when we use the, it's the same thing when we look at the completely custom piece, but the important thing to understand is that we aren't using any of the delegates, but the completely custom one doesn't even have a delegate. No one's ever written one for it. So this would be something that we built and prototyped very quickly, and we're able to test without going through all that extra engineering or configuration effort. Furthermore, that XML file we mentioned does not exist in this context whatsoever.
So I guess that's, based on what you shared with me, that's quite a dramatic difference with some of the other commercial tools that you used in the past.
What it makes a difference of is when we can test, right? So did we get something working and then go off and build the delegates, or do we start testing now? That's one question. But second, it does, again, lead to a couple other pieces. If I link in these other automation delegates and things effectively to test my application, I'm running slightly different code than I'm actually running in production. That makes me a little nervous to begin with. But on top of that, it also means that there's multiple sources of errors and problems. None of that's happening with this application right now. This application that's running in the background is effectively the same one that you could go off and deploy. And that's an interesting advantage to what we're doing.
Right. Okay, so thank you, Mike. I think that was very informative just to understand what's actually going on behind the scenes. So creating a checkpoint is actually very easy. You take the target, you drag it to an object, and we have actually two choices. We can select the object that is the strip for displaying these icons, or we can select the icon itself and bootstrap to the strip. So I'll just select this display eBay, and that's going to come up and first of all show us what we've selected to make sure it's the right thing. But in the next step, you'll see that you have access to all the properties of the object on the screen, including those specific for Flex. Now, in order to make the right checkpoint here, what we want to validate is the properties of the selected item. So for checking the properties of selected item, we're going to the parent, which is the actual strip.
And actually, I'm going to pause for 1 second, so I'm going to throw something out there. What just happened was actually quite interesting, because what we had selected is you had eBay, and eBay was a single selected item on the screen somewhere, but TestComplete is aware of the object hierarchy of these various pieces in here. So what we were able to do by clicking on the buttons, we'll say, well, yes, I know we selected eBay, but it turns out that we didn't really want the eBay icon. What we really wanted to do was verify that eBay icon is what's selected in the parent. So by clicking that one little button there, it navigated the Flex hierarchy and said, oh, okay, well, what's the parent of this particular piece? I actually just find that very interesting, that hierarchy is so easily navigated.
So we have actually three choices: selected child, selected index, and selected items. Selected index is the simple default choice, but it may not exactly work in the case when some other items are added to the strip. So we're going to check the selected item and check its ticker.
So before we even go further than that, what we really just did there was we said, you know what, as a methodology, instead of building this on an index or something that's positioned on the screen right now, let's dive into the data that actually made that icon render. And that data happens to be one of these quotes in the background, and it has source, which is where the image was, and what the open and the officers and what the low and exchange and all these sorts of things were. And what Sergey did was actually dove into the source that created that image and said, in that value object, what I'm going to do to verify this is I'm going to look at the ticker property. So thinking about this, what we did is we looked at the display, we found eBay, we said, okay, from eBay we'll find out the parent, which was this strip of things. We'll look at what's selected in the parent, and then further, instead of just worrying about the selected item and having to worry about that as a string or an index, we'll actually dive down into the data that created that and say, let's look at a property in the data that created this object on the screen, and if that's what's selected, then we have the right selected item. It's the level of which we're able to dive into things that makes us so interesting.
So we've created that checkpoint. We're also going to check that the other data presented elsewhere about eBay is correct. So similarly to what we just did, is just a simpler object, we're going to check that eBay is displayed here in the quote. And similarly, we can build checks on the price quote, the percentage up, and whatever is relevant. You have to obviously keep in mind the nature of the data. So if you're testing the fact that it's eBay rather than a specific price point, right? If you want to keep testing the application itself, then you actually don't want to specify the checkpoint on the price. So we can now choose a different stock and follow a similar pattern to validate the application, because obviously if there's some sort of an error and eBay always comes up as the selection, that's not what how we actually want the application to work. So we're going to exercise it a little more. And just for the benefit of time, I'm not going to create a lot of checkpoints here, just the principle that we're illustrating. So we've selected Apple. We've got the Apple icon selected here. We're going to similarly create a property checkpoint and navigate to that object. And we're going to go to the parent, to the flex properties, to the selected item. There it is. And make sure that it actually is Apple. Okay. So now you see that this message checkpoint has been added to your test. So we should be all square. Now we stop the test. That's going to process the information and create this keyword representation that I talked about. Something that did not get recorded. Where we actually got the not only all the steps identified that we clicked through, but also we captured the screenshots of what the application looked like at any specific point in time. And that obviously creates a boatload of convenience because, A, you have an exact description of what your test did, with all the data, and then you have the visuals for that, and every visual would have the image on the screen and the representation of some of the things that you actually click when creating a test. Running the test interactively to validate is very simple. You select the test, you run it, and upon completion, you'll get a very detailed log file that would, now TestComplete is performing the execution of the test according to what we actually recorded. And upon completion, you'll get a step-by-step log that not only checks the, not only represents the flow of the test, but also for every step gives you the images, the comparison of the images. That corresponded with the steps that you took. There is a lot more, obviously, to this tool than just being able to record the screens, step through them, and create checkpoints. There's a lot of material that we have on SmartBear website at www.smartbear.com. There are dozens of videos, some of them specifically devoted to Flex and Flash testing. There's actually a relatively detailed webinar back from February when we introduced the improved ability to test Adobe that we covered all of that in detail. So I would refer you to that source of information, invite you to visit our website. So at this point, let me turn to the questions and see if there's anything more than we talked about that our audience would like to know.
So Sergey, why don't we split these up? I think the first one about TestComplete and HTML5 is on you, and then I'll hit a couple of the Flex ones, okay?
Mm-hmm. Yep. Yeah, as long as I All right. So I was trying to expand the question box. that took some time. Okay. So the first question, does TestComplete test HTML5? That's actually a very interesting question because nobody knows what HTML5 is at this point. It's a moving target. We do have some capabilities to test HTML5 out of the box, but the problem with this is that it constantly is adding features. So I think with that kind of dynamic, it will be an evolving project for us. We have a commitment to support HTML5 as we have to pretty much any web technology out there, and we support quite a number of them. So with that, the short answer is yes. The long answer is it's going to continue to support HTML5 in whatever direction that standard evolves.
Okay. So very quickly, the delegates, or the question about delegates versus accessibility. In Flex, we have our accessibility implementations, which are for things like screen readers and various opportunities for the interactions to be captured so that we have accessible implementations. And there is a lot in common between the accessible implementations and what delegates do. And in fact, TestComplete can take advantage of some of those pieces as well to make things work. However, inherently, they're actually two separate implementations. So for every single piece in a component in Flex, you'll actually see that there is an accessibility implementation and there is a delegate implementation for testing. So those are two separate classes. So really the short answer to your question is that the work that has to be done to normally use an automated testing tool like this is on top of the work that has to be done to be able to do accessibility if you're going to use a traditional testing tool.
And Mike, correct me if I'm wrong, accessibility is basically a layer that supports MSAA APIs.
Yeah,
right?
it does. And again, it's basically a method, again, of interaction, but it also has other features, like, for instance, knowing where an object is located so that a zoomer or a screen reader can be refocused. There's a number of things that go along with it. However, even though they are very similar, they are actually two separate implementations in Flex.
Right. Yep. And while we have a somewhat obsolete mode of testing Flash using Accessibility API, that's not required for performing testing as we showed either. So it's, while it may be relevant to your project for a different reason, that's not necessary for using TestComplete.
Right.
So, Mike, let me take a couple, and then I'll punt you the question about dynamic components.
No problem. Take your time.
Oh, I actually know what that's about. I'll talk about that as well. So I'll take the following two. What about Adobe Air applications? That's a simple answer. We support testing Adobe Air as well. It's just a type of the desktop application we test with TestComplete. We support it all the way through Air 2. Whatever the latest minor version is. With existing TestComplete, we're scheduled to release Air 3 support with TestComplete 8.7 due out in mid-December. It's a little trickier of a question. When can we start testing our applications with Internet Explorer 10, which in itself is in beta? And there's a little bit of a challenge using beta versions because, in our experience, right at the last moment, a vendor will slip something in that completely breaks our method of interacting with that application, whether it's Internet Explorer, Firefox, or Visual Studio. So generally speaking, we plan to open a beta that will support Internet Explorer 10 sometime next year, but at this point the dates are not known. The best I can suggest is that you monitor our forums on SmartBear.com. Has a very active community, and anything that relates to releases, open betas, and any other announcements will appear on the forums. We do have actually a separate forum chapter there for Adobe Flash and Flex. So if you have any questions, specific questions about testing these technologies, or you've experienced some difficulties, you could pose some questions there. Let's see, when? Okay, developing this, developing that. Let me quickly handle this question, Mike, and then I'll pop it over to you. How can we overcome the dynamic components? I believe Natalie refers to the components with changing names. We have a number of approaches, well, at least two, in TestComplete that helps you deal with that, because obviously the object identifiers will change. We have a feature called name mapping, which is a very rich module that basically allows you to build abstractions over names. And you can use that to mask any object name changes with wildcards. You can also use search by XPath with kind of similar approach to wildcards, but that seems to work particularly effectively for some folks with web applications. There's a big webinar that we did on name mapping. It's also available as video on demand from our website, so you're welcome to visit and watch that. Okay, so we probably have time for one more question. Let me see, Mike, whether I can find a good, challenging one for you.
If not, there's obviously a lot of these are for you. If you want to hit a bunch of them in bulk, at least we can get some people some answers. That's fine, Sergey.
All right. Graph, Flex, Firefox 7, Chrome, mobile Air applications. So this is all roadmap stuff. Okay. How did identify? I'm not sure. Okay, that's also for me. How did the tool identify the Flash objects? I'm not sure if I missed it, but we do need to do something before starting the recording, or does TestComplete identify them by itself? There is a method with the Flash injector where there's absolutely nothing that you need to do. You just need to install and configure the Adobe debug player. Nothing ever needs to be done to the application itself, so no code changes, no build changes, no anything. With the method that I used, there are 3 files, HTML page and a couple of Swift files that need to be copied and referenced from the testing projects, and those pages basically take care of loading the right Swift and opening up the application for testing. Okay, well, I think at this point we will have to wrap up the webinar. It's been a pleasure having this audience, and particularly Mike Labriola as a presenter. The recording of this webinar will be available on our website. We'll send an announcement about that to the attendees. And please keep in tune. We have very interesting webinars. We will send, we'll post invitations, we'll send invitations. We'd like to have you over for another one. In conclusion, our contact information. Website for Mike Labriola, Digital Primates, one of the premier consulting companies developing Flex applications, and SmartBear.com, one of the leading companies providing automated test tools for quality anywhere. Thank you for your attendance. Have a great day.